is Jacqueline Means, and I'm also known as the STEM Queen, and today I am so excited to be performing for you guys here at the USA Science and Engineering Festival. Now, I have some super exciting experiments planned, so let's jump right into them. For my first experiment, I have this cool bowl of white powder. Now, you guys might think it's salt or borax or even sugar, but it's none of those. This is called a polymer. Now, polymers are really cool because they act as little sponges. So every little particle here is going to act like a sponge and soak up the water I'm going to put in it. Now, if you watch closely, you'll see it will expand and soak up all that water and look like snow. Now, this is a cool experiment because not only does our polymer soak up whatever color water we put in, also whatever temperature water we put in. So if this had been boiling hot water, you could literally see the steam coming off of it because it would be that hot. And if it was ice cold, it would feel like real snow. Now, I want to have some purple snow today, so I'm going to put a little bit of purple food dye in my water, swirl it up, and pour it in. And you can see, just like that, I have changed the color of my snow. And now it's purple. Now, this is a really cool experiment, definitely one of my favorites, but we have some even better ones coming. So, moving right along. Next, I've got another bowl, not filled with a polymer, but a clear liquid. Now, what do you guys think this is? I'm guessing you guys are saying water, maybe even vinegar. Some people have said isopropyl alcohol. This is neither of those things. This is calcium chloride. Now, calcium chloride is cool because when it gets in contact with sodium alginate, which is what's in this bottle, it links up all these molecules and turns this liquidy substance into a congealed gelatin-like form. Now I'm going to show you guys exactly what I mean. So I'm going to take it, swirl it up. I don't think it worked. Oh, what's this? Oh my God! An alginate worm. Just like that, I've made a worm. And the cool thing about this is you can eat it. Now, I won't be eating it because I don't think it tastes that good, but still super cool. Now you guys can see, totally blends in. Another cool thing about these is that they're definitely more visible if you add food dye. So I'm going to take a little bit of green, pour it in to my sodium alginate mix, shake it up for a real one so it's all green, like that. And now take it. Yeah, you can definitely see the neon. And there you go, alginate worms. Now I am going to show you guys something that you can actually do at home. All you need is a water bottle, water, and vegetable oil. Now I have 300 milliliters of water and about 170 or so milliliters of vegetable oil. So now I'm going to take my water and pour it into my bottle. So I'm going to take some blue, squeeze it in, and swirl it up. Nice navy color, really cute. And now take my vegetable oil, pour it in. Now I'm sure you guys have learned all about density. Now density is kind of like saying what liquid is heavier than the next one. So you can see here my oil is rising to the top because it is in a sense lighter than the water. And that is why it's sort of floating on top of our water. And now that my oil is in, I'm going to take my Alka-Seltzer tablet, break it up into little pieces so I can get my lava lamp going. And you guys will see in just a second the bubbles start to rise up from the bottom to the top. You can see them coming up now, looking so cool. There's our home lava lamp. And now for my final experiment, I am going to take this tray with my Erlenmeyer flask on it. Now, I've got my tray to catch my sort of residue, which you guys will see in just a moment, and my Erlenmeyer flask of not water. This is hydrogen peroxide. Now, I'm sure you guys have seen hydrogen peroxide in your houses in that little brown bottle, but that is usually only 3%. This hydrogen peroxide is 35%, so it's much more powerful than the one that you guys have at home, which means it's more corrosive and abrasive and just a lot stronger. So you definitely don't want this to touch your hands, which is why I have my handy dandy gloves on. And I'm also going to put on some extra PPE, my sparkly pink goggles, to protect my eyeballs. So now I'm going to take a little bit of pink food dye to match my pink gloves and my goggles, pour some in, and swirl it up, making sure I get every drop of hydrogen peroxide to be colored pink, just like that. And now I'm going to take some dish soap and put it in and then swirl it up so everything's nice and mixed together. And you'll start to see some bubbles form, just like that. And now my final ingredient is going to be potassium iodide. Now this is going to be my catalyst, what makes this thing blow up and get everywhere and look really, really cool. Now, what can you find potassium in? If you said bananas, you are correct. Now clearly this is not a banana. This substance kind of looks like salt or maybe even crystallized sugar. But yeah, you can find potassium in bananas, but this is very clearly not a banana. But still, really cool kind of little sciencey link there. And now I'm going to pour this in, and you guys are going to see my elephant toothpaste. Ready? 3, 2, 1. And just like that, you can already see an exothermic reaction, steam coming off of it. Super cool. You guys can see all the bubbles from our soap, the pink from our food dye. It looks so, so cool. But yeah, I hope you guys had a lot of fun with me. I hope you learned a lot and had a good time with me learning science and STEM. And I hope to see you guys on my Instagram at STEMQueenDE, where I post cool videos like this all the time. Have a great rest of your day and enjoy the USA Science and Engineering Festival. Bye!